70% of our planet is covered by vast, mysterious oceans, stretching from pole to pole and shaping the very climate and life on Earth. And it's not just the water that's important. About half of humanity lives within a short drive of the coast, drawn by the resources, beauty, and opportunities the sea provides. Our lives, cultures, and economies are deeply intertwined with the ocean's edge, even as our world becomes more digital every day. Yet, despite our connection to the sea, the backbone of our digital existence, our photos, emails, and memories, are stored far from the water, in massive landlocked data centers. These facilities are technological marvels, but they come with a cost. They generate enormous amounts of heat, requiring vast quantities of electricity and water just to keep the servers cool and running. In a world facing energy and water shortages, this is a growing concern. But what if there was a way to harness the natural cooling power of the ocean itself? What if, instead of fighting the heat, we embraced the cold depths? That's exactly what Microsoft set out to explore with Project Natick, a bold experiment to see if underwater data centers could be the future of cloud computing. The team engineered a sealed submarine-like pod packed with servers, then carefully lowered it into the chilly waters off Scotland's rugged coast. For 2 years, this pod sat quietly on the ocean floor, braving the currents and pressure, all while running real workloads and storing real data. When the pod was finally retrieved, the results were nothing short of remarkable. The servers inside had experienced 8 times fewer failures than their land-based counterparts. The hardware was cleaner, less corroded, and more reliable, proving that the ocean's unique environment could actually extend the life of our technology. It turns out that the cold, stable, and oxygen-free conditions deep beneath the waves are ideal for sensitive electronics. The ocean acts as a natural coolant, and the absence of oxygen means less corrosion and fewer breakdowns. It's a surprising twist. The harsh, remote seafloor might just be the safest place for our digital world. So, as we look to the future, let's dive deeper into the story of the blue cloud, a new frontier where technology and the ocean come together to shape the next era of computing. Every click online happens on a real server, and those servers get hot, fast. Data centers are giant, heat-spewing warehouses, cooled by massive, energy-hungry systems that burn through electricity and billions of gallons of water. It's a constant, costly battle against physics, especially in hot, dry places. The ocean flips the script. It's a vast, stable, near-freezing heat sink. Instead of fighting the environment, you use it. Just a simple heat exchanger, no giant fans or chillers. The cold seawater passively draws heat away, silently and for free. The ocean does the cooling work for you. In 2015, Microsoft launched Project Natick, a bold experiment that began as a simple question: could a data center operate underwater? At the time, it sounded like science fiction, a radical departure from the traditional land-based server farms that power the internet. But the idea was driven by a real need. Data centers consume massive amounts of energy, especially for cooling, and are often located far from where people live. What if you could harness the natural cooling power of the ocean and bring data centers closer to coastal cities where most people reside? The first step was a small-scale trial. Microsoft engineers built a compact, cylindrical pod and submerged it off the coast of California for 100 days. This initial test was a resounding success, proving that servers could survive and operate reliably beneath the waves. Encouraged by these results, the team scaled up. They designed a full-sized pod, filled it with nitrogen to prevent corrosion, and packed it with 864 servers. This massive unit was then deployed off the Orkney Islands in Scotland, where it would remain underwater for 2 years, facing the true test of time and the elements. When the pod was finally retrieved, the results were astonishing. The servers inside looked almost untouched, as if they had just been installed. Even more impressive, the failure rate was just 1/8 of what's typically seen in land-based data centers. a dramatic improvement in reliability. The secret lay in the ocean's cold, stable, and oxygen-free environment. Without temperature swings, humidity, or oxygen to cause rust, the servers were protected from the usual wear and tear. And with no humans entering the pod, there was less risk of accidental damage or contamination. This unique setting eliminated many of the problems that plague traditional data centers. No overheating, no corrosion, and no need for constant human intervention. Project Natick proved that underwater, lights-out data centers could operate autonomously for years, requiring only minimal maintenance. The experiment not only demonstrated a new way to build and run data centers, but also opened the door to more sustainable, energy-efficient solutions for the future. In the end, Project Natick was more than just a technical success. It was a glimpse into the future of cloud computing. Underwater data centers aren't just cool, they're fast. Latency or delay is all about distance. Most people live near coasts, but data centers are often far inland, adding lag. By placing pods just offshore from major cities, you slash the distance data travels. This means faster gaming, smoother video calls, and real-time tech like remote surgery. It's edge computing at its best, bringing the cloud right to your doorstep. Imagine a ring of pods off every major coast, serving millions with ultra-low latency. The internet gets fundamentally faster for half the world. Why isn't everything underwater yet? What's holding back this revolution? Traditional data centers take years to build. Land, permits, and construction all add up to long delays. Underwater pods are factory-built, standardized, and can be deployed in just 90 days. Need more capacity? Just add more pods. Build, ship, and sink a pod exactly where demand spikes, anywhere in the world. This agility means cloud providers can respond instantly to new trends and shifting needs. Pods can even be moved or redeployed, creating a truly nomadic infrastructure. Imagine a fleet of data center ships supporting global events or shifting with demand wherever it's needed. The data center becomes a mobile, on-demand asset, ready to serve the world. Microsoft's Project Natick proved that underwater data centers could work, showing the world that servers could thrive beneath the waves. But while Microsoft's experiment was a technological milestone, it was just the beginning. Now, China is taking this concept to an entirely new level, scaling it up from a single research project to a massive real-world deployment. Highlander, a leading Chinese tech company, is building the world's first commercial underwater data center off the coast of Hainan. This isn't a small pilot. Highlander is deploying 100 enormous pods on the ocean floor, each packed with servers and advanced cooling systems. Together, these pods will deliver enough computing power to support the digital needs of an entire small city, powering everything from cloud services to artificial intelligence. Each pod is a massive 2,300-ton vessel, roughly the weight of a fully loaded passenger jet. These pods are carefully lowered to the seabed and connected to the mainland by thick power and fiber optic cables, ensuring a constant flow of electricity and data. The engineering behind this is staggering, requiring precision and innovation at every step. The payoff is huge. By using the ocean's natural cooling, Highlander's underwater data centers are projected to save an incredible 122 million kilowatt-hours of electricity and over 100,000 tons of fresh water every year. That's a dramatic reduction in both energy use and environmental impact compared to traditional land-based data centers. For China, this is more than just a technological leap. It's a strategic move to grow its digital economy while slashing its carbon footprint. By shifting data infrastructure offshore, China can support its booming tech sector and urban growth, all while reducing reliance on coal and cutting greenhouse gas emissions. And this is just the start. Plans are already underway to build more underwater data centers along China's vast coastline, turning the country's coastal waters into a new frontier for digital infrastructure. Each new site will bring more capacity, more efficiency, and more innovation. What was once a futuristic idea is now becoming billion-dollar infrastructure. These projects are transforming not just how data is stored, but where the world's digital backbone will be built in the decades to come. The ocean, once seen as a barrier, is now becoming the new home for the cloud, ushering in a new era for global computing. What about the environment? Studies show the heat from these pods dissipates within inches, no boiling the ocean. In fact, the pods quickly become artificial reefs, attracting marine life and boosting local biodiversity. The sound is minimal and the impact is surprisingly positive. Site selection and non-toxic materials are crucial, but so far the results are promising. Using seawater for cooling slashes, fresh water use, and energy consumption. The pods seem to integrate naturally, even enhancing the underwater ecosystem. It's rare for heavy tech to coexist so well with nature. There's a catch: maintenance. Once a pod is sealed and sunk, you can't fix a failed server. It stays failed. The solution: build in redundancy and resilience, so the system keeps running even if some parts fail. When enough components die, you retrieve the whole pod for refurbishment. Retrieval is complex and costly, and while a pod's offline, others must pick up the slack. Plus, each pod relies on a single power data cable. If it's damaged, the pod goes dark until repairs. You need a network of pods for true reliability. Maintenance is the trade-off for all those benefits. What if you could make these pods fully autonomous? Enter nuclear power. Submarines have used compact reactors for decades. Why not data centers? A nuclear-powered pod could run for 20-30 years anywhere in the ocean with just a fiber cable for data. No vulnerable shore power needed, and multiple data cables could add resilience. The idea is controversial. Security, regulation, and environmental risks are huge hurdles. But from an engineering perspective, it's compelling. The military is likely interested, too. Imagine secure, autonomous, underwater command hubs. It's a wild idea, but not as far-fetched as it sounds. From solving a heat problem to envisioning nuclear-powered pods, the cloud is heading underwater. It's cooler, greener, and faster, no longer a distant dream, but a reality being built today. The ocean, once the cradle of life, could soon cradle our digital world. It's a radical shift in how we think about the internet's physical home, but it all comes down to trust. Would you be comfortable knowing your data lives on the ocean floor? Let me know in the comments. And if you're fascinated by tech like this, dive into that subscribe button. Thanks for watching.